And just like that, we've made it to 3.2. 3.2 is talking about polynomial functions and their graphs. The goal of the whole section is to graph a sketch of a polynomial. So be given like a generic polynomial function and be able to go through a number of different steps, sort of find different information about it and use that information to make a graph. So it's just that one goal for the whole chapter. So this is sort of a good news, bad news situation. We really have just one thing we're trying to do, which is make these graphs, is the good news. The bad news is that there are a number of different steps that go into it. So we're going to have to build up a few different techniques and then just sort of review a couple things that we know already. First and foremost, let's just sort of define, maybe I won't say define, let's sort of get our form for what a polynomial function is going to look like. So we've definitely done polynomials before. As a function, sure, it's just f of x equals whatever our polynomial looks like. So polynomials generally, right, it's sort of like constant numbers multiplied by like variables raised to positive whole number powers, and then it's a whole sort of sequence of those either sort of added or subtracted together. The notation we're going to use is so a sub n times x raised to the n. So the a sub whatever is going to be a constant term. It's our coefficients. And then the x is our variable, right? F of x is the input variable, and then the n is our exponent. And so a polynomial was a whole series of these guys, right, kind of added up together. And so our notation is going to look something like this. So we're counting down from however much, n could start at 10, 20, 30, probably for us more like 3, 4, 5, maybe 6. So counting down, right, we'll sort of do dot, dot, dot. Fill in the blanks, so down to sort of a sub 2 with an x squared, a 1 with like an x, which would in theory be x to the 1, right? All the way down to just a constant term on the end, which we'll call a0. In theory, you could even sort of call that times x to the 0, right? Anything to the 0 is just going to be 1. So in theory, you could even count the powers down all the way from whatever your n is, 6, 10, 20, all the way down to 0. We just sort of leave off some of these powers at the end because it's just not what we're used to. We're not really used to writing them that way. So the degree of a polynomial is whatever the highest exponent is. So that's going to be our value n, right? It's the highest power. By default, we're kind of always going to be writing our polynomials in descending order, so biggest terms on the left down to the smallest, more or less in order, right? So whatever our sort of first term is, we're going to get our degree from there. What we call the leading coefficient. So the leading coefficient is going to be whatever this number is, a sub n, on our first term, right? So whatever our like highest term is, the leading coefficient is the number in front, right? So just to sort of put this on the side here, the idea is, right, a sub n is a constant, and all of our powers, right, all the exponents are positive whole numbers. So we're not going to have to necessarily do within our polynomials any kind of negative exponent or fraction power. That's just not going to be in play here, which is sort of one less thing to worry about. So that's good. Let's just identify a couple of these degrees and the leading coefficients. We're going to be sort of using these to do our graphs. This is going to tell us some information about the graph. So say, for example, maybe I have negative 6 x to the 5 minus 3x cubed plus 14 x squared minus 10. Super generic polynomial. We're essentially just sort of pulling numbers out of a hat here. We're not really trying to do anything super fancy. So our degree is going to be this highest power. So our degree is 5. Right? It's the largest exponent on all of our terms. The leading coefficient is going to be whatever the number is in front of that term. So positive or negative. So we're going to say our leading coefficient here is negative 6. The idea is that the behavior on the graph, as you get further and further out to the like bigger and bigger x values, the leading coefficient and the degree, that like first term, that biggest term, is really going to have a lot more say than the other terms, which is one of the reasons why we're sort of focusing on it. The degree of the polynomial also has an impact in terms of how many like sort of up and down like turns, just how many sort of like up and down movements the graph will make. There's a lot of things that come from that. The higher the number, in theory, the more complex the graph can look, meaning the more sort of like up and down turns it can take. If I have another polynomial, one of the things that we're going to see is sometimes we'll see polynomials that are kind of like, we'll call them maybe like prefactored, which is going to be something that's actually very helpful. But as far as finding a degree and finding a leading coefficient, it actually makes that maybe slightly less obvious. In a regular polynomial, if there's one that's all expanded and it's sort of out in its sort of long form, you're obviously just looking at the first term, assuming you're in descending order, and you're just getting the degree and the sort of leading coefficient from there. If you have something prefactored, let me say, for example, right, 4x, maybe this is like x minus 2 squared, and then this is times like 3x plus 4 or something, right? So maybe we have a polynomial that's sort of factored already. So instead of being expanded out into its long form, it's sort of condensed down into its factored form. So it's this product of these smaller polynomials. Again, the factored form can be really, really useful. The one thing it just doesn't give us in quite as easy a way is it doesn't tell us the degree quite so fast. It doesn't tell us the leading coefficient. One option is to just like multiply all this stuff out. That's going to take a minute, right, to actually like formally do all the multiplication and find all the different terms, combine our like terms. That's possible, but it's definitely a process that's going to take a minute. In theory, right, we're not really using these like other terms. We only care about the sort of biggest term, this leading term. So what we're going to do, if I have a prefactored version, is I'm just going to find this leading term, and the way I'm going to do that is I'm going to essentially sort of look at what are the values I'm getting from each of these sections. What's the biggest thing that I'm sort of getting from each of these like three chunks? So obviously 4x is a part of it just by itself. That's going to be a part of it. That counts. If I have this middle term, so x minus 2 quantity squared, so if I sort of expand that out, FOIL it out, or do the sort of box multiply, x minus 2 times x minus 2, the biggest term I'm going to get out of that is x times x, which would be an x squared. So that's going to be a part of making our leading term. And then over here, the biggest thing is the 3x. So my leading term is just going to be the product of all those three things together. 4x times x squared times 3x. 4 times 3 would be 12. X times x squared times x. That's 4 total x's. So my leading term here is 12x to the 4. I don't need to find all of the rest of the terms. Those other terms aren't going to affect the degree. They're not going to affect the leading coefficient, right? This is only stuff that's coming from that first term, the biggest term. And so we can get to that pretty easily, honestly, by just sort of multiplying the biggest thing from each of these all together is going to get us the overall largest thing. So once I have that, well, then it's just a matter of saying, okay, well, then my degree is the power. So my degree there is 4, right? And my leading coefficient is going to be the number, right? It's going to be 12. So finding a leading coefficient, finding a degree, even if we have something that's pre-factored, is definitely still possible. It takes an extra minute to sort of do it if we have to sort of partially expand this out, but it goes pretty fast. It's not the full multiplication because I don't need all of these individual terms. If I have it just sort of already expanded, even better. I'll just pull right the coefficient in front as my leading coefficient. The highest power, right, that sort of goes with it is going to be my degree. And that's the idea. So that's our intro. Let's see if we can sort of put this to use in the next video.